You've had a taste of working with XAML, and as you've seen, XAML is pretty simple. It's just a grammar of XML. But it does provide several different ways to set property values. We can cover pretty much all of XAML in 4 basic concepts. We'll look at simple properties and type converters. We'll investigate more complex properties. We'll look at markup extensions that provide non-standard ways to set properties. And we'll look at attached properties, each individually. Dragging a button control onto the XAML design surface creates several properties. You saw that already. The markup in the XAML counts on the button class having a content property, a height property, horizontal alignment, margin, name, vertical alignment, and width properties, because by default, all of those get created in the markup. And of course, if they exist in the markup, there better be corresponding properties in the button class in the .NET Framework. Now, some properties are just simple strings. For example, the content and name properties of the button were just strings, like button1 or click me. But others are more complex. Let's think about those, the ones that require some extra effort. For example, what about the height and width properties? We set those as a string, but clearly those are numeric properties. They're numbers, they're not strings. But the markup supplies their values as strings, their attribute values as strings. Someone had to think about all this as they first started designing XAML, thinking, how are we going to let the users use XML, which requires strings for attribute values, but actually treat them as numbers? Along the line, there has to be some code somewhere that converts those strings into integer values for the height and width properties. And of course, this works because the integer class provides a built-in conversion from string to integer. Other properties, however, are even more complex. For example, the horizontal alignment and vertical alignment properties. You'll remember that these are an enumerated value. From bottom, center, stretch, or top, center, left, right, or stretch, to some enumerated number, a numeral value, because enumerations are stored internally as some sort of number. So we need to convert from a string, the letters B, O, T, T, O, M, to a number which corresponds to that enumerated value. Someone, somewhere, is doing that for you. Let's look at the margin property. It adds its own set of issues. For the margin property, you can supply a single value, and that applies to all 4 sides. You can supply just 2 values. You haven't seen that yet, but you can. If you supply just 2 values, the first value applies to the left and right margin, and the second value applies to the top and bottom margin. You can also supply 4 different values, and in that case, they supply the left, the top, the right, and the bottom margins individually. How can this be? Who's taking those 4 comma-delimited values and converting them into something that can be rendered as a control's margins at runtime? Well, the margin property really represents a thickness structure. A thickness structure in the .NET Framework contains 4 integers. Setting the property in XAML calls the constructor for the thickness structure, and it copies the values you've entered into various properties of the thickness structure. It also converts them from a string into integers. Somewhere there has to be a converter to read that comma-delimited list of strings and convert to a call to the constructor for that class. You can create your own type converters as well. This one is built into the .NET Framework. And one thing to note, XAML is case sensitive. That is, the name of the property margin has to have an uppercase M. But the values are not case sensitive. So where I used bottom with a capital B, could have used a lowercase b. They would have worked that out just fine. XAML's case sensitive, the values themselves are not. Now, type converters work fine, and there's a bunch of built-in ones, and we could also create our own. But some properties can't be represented by a single value. What if you want to specify the background of a grid control as a linear gradient? You can imagine a gradient which moves from one color to another across the width of the grid. You need to specify both colors. You need to specify at which point we switch from one color to the other. There are a number of different things we need to specify, and we can't represent that behavior with a single value. Properties of elements that are themselves objects with properties, like the linear gradient, require some special care. We'll represent them as nested elements, and we'll name them parent.property, like grid.background. So rather than being attributes, these properties will be represented as elements instead. Let's examine some of the things we've been looking at in Visual Studio. In the markup, I've cleaned up our button so it fills the entire space, so I can demonstrate creating a linear gradient background for that button. To do that, I'm going to go to the Properties window and search for background property. There it is. And if I click on it, it brings up a designer which allows me to set the linear gradient background. You can see I could choose a null brush, a solid color brush, a gradient brush, or an image brush. I want a gradient brush. And now I can specify what color I want in my gradient. And here, specify at what point we switch over from one to the other. Let me pick a color which actually shows something. I'm not good at this, designer. Really, I'm not. Okay. If we set the color, of course I selected the grid, not the button, so I better go delete the button so we can actually see the grid. There we are, and there's our gradient all set up. Now what do we have here? I've set up a linear gradient brush as the background for this grid in our markup. Because the linear gradient brush requires me to specify gradient stop elements, which indicate where within the layout from left to right of this linear gradient I want the colors to change. And you know these colors are awfully hard to see. Let me change this one to be black so we can actually see it, and make this one be white so we can really actually see it. There we go. Not very exciting gradient, but at least you can tell what's going on now. Here, the offset says at around 1/4 of the way through this thing, start switching away from black and move toward white. If I change this to 0, you'll see here at 0, we start moving from black towards the other color. And the other color ends at 1, which is the right-hand side. These offsets go from 0 to 1, from the left-hand side to the right-hand side. And you can change these to be any value you like within 0 and 1. So if I want to make this 0.25 and make this one be 0.75, then you can see that at 0.75, that's 3/4 the way across, we have complete white. We have complete black up to 1/4 of the way across. And in between, we have the gradient that goes from black to white. That doesn't matter here. You can investigate linear gradients. My point was to show that we had to use this grid dot background layout in the markup because this is a complex property. There was no way to identify the behavior of this brush without including all of these child elements. And to make that happen, we had to use the parent dot property syntax for this linear gradient brush. Now at this point, let me show you that you can use that syntax for any property. Within this grid, let me put a button back in there. And you've never seen me do this, but you can just type the button directly by hand. You don't need to drag it on from the toolbox. And sometimes I find this easier, because here I can just set the content and the name, without having to delete all sorts of extra properties. Okay, so we have our content and name property set, but what if we want to set a width and height? Well, of course, we could set it right here as attributes, but you could also here say button dot height and specify height of 23, or button dot width and set a width of 75. So you can see that you can use that syntax for any property, not just complex properties. But most people don't. For simple properties like this, you normally just use attributes, as we did for content and name. But for complex properties like a linear gradient brush, you'll want to specify those using the parent.property syntax. Usually, standard XAML markup provides the functionality you need when creating your markup, but sometimes it's just not possible to set the property value at design time. Some properties need to be set dynamically at runtime. For those, you need to use a markup extension. That allows you to set the property in a non-standard way. You can specify the markup extension as a nested element or as an attribute as well. If it's an attribute, it's always surrounded with curly braces. That indicates the value supplied at runtime. Declarative binding, which we'll look at in detail elsewhere, requires markup extension. Here's one way to do it. We could say the property we're trying to bind to equals, well, we don't know the value right now, we need to get it at runtime. And to get it at runtime, we have curly braces, the binding object, which we represent with the text, binding, and then properties of that binding. We need to specify what object to get the property value from, and which property of that object to retrieve at runtime. You can also use the child element syntax, which you've seen already. Here we can specify object.property, whatever property you're trying to bind to, and inside specify the binding element. The binding element will have properties that you'll set indicating which object you're retrieving the binding from and which property of that object you want to bind to. Well, this is all a little bit abstract, so let's try a simple example which uses a markup extension to supply some declarative data binding. We won't use the second syntax because you've already seen that syntax. Instead, we'll use the first syntax on this slide, which indicates using a markup extension. Here in my design surface, I have my lone button. I'd like to move it a little up so I have room for a text box control as well. So let me place a text box onto this layout. I'd like to be able to type text into that text box, and whatever I type, I want to have become the content of the button. Think about it. You can specify the content of the button by typing into the text box at runtime. How do we make that happen? Well, let's clean this up so you can see all the attributes here. Well, for this text box, it is the text property that defines what appears within the text box. So I'll put click me in there, and that now is the text of this text box. Coincidentally, it happens to match the content property of the button. But I don't want to hard code the content of the button. I instead want to get this by binding it to the text property of this text box. Now, I've mentioned before that in XAML, elements don't have to have name properties unless you're going to want to refer to those elements. At this point, the name of the text box is textbox1, and that's what I'll use to refer to this text box. Here, I don't want to hard code the content property of the button. I want to retrieve that value at runtime. I need a binding. So I'll put a curly brace there, and now in there, insert a binding. Now, what binding do I want to use? I want to specify an element name which indicates where to get the property from. That element is textbox1. I also want to specify a path which indicates which property of the text box to retrieve the value from. And I'll use the text property. And look what happens. Now, immediately, the button updates to say click me. Down here, we've set the text to be click me. We've pulled that text from this element and used it bound to this content property. That's what this curly brace markup extension does for us. It doesn't set the property right now, it sets it at runtime. And of course, the designer is rendering this layout as if it was running here within the designer. So if I change this to be something else, immediately the button updates to match. And of course, the same behavior would happen if we ran the application. So using this markup extension, we can bind one property of a control to a different property of another control. It's an incredibly powerful concept, and it's only available because of this markup extension. There's a third way to use properties in XAML, and that is an attached property. If you nest a control within a grid, you specify its row and column using the grid.row and grid.column properties. Where do these properties come from? If you place a text box within a grid cell, the text box has a grid.row and grid.column property, but the text box didn't supply those properties. Why would a text box have a grid.row and grid.column properties? They don't. The grid control adds those to all of its child controls. In other words, they're attached properties. They get attached to the child control by the parent control. The properties appear as if they were properties of the text box class or whatever the child control is, but they're actually defined in a different class, that is, grid in this case. They have a very specific syntax. The syntax is defining type dot property name, grid.row, grid.column. They aren't actually properties of the child control. They aren't actually properties of anything. The compiler converts them to method calls on the parent object. So the defining class has to provide, we know that, for example, the grid control has a getRow and setRow method. So when you use the grid.row property, the compiler converts it to a method call to get or set the row property on the grid. So the grid must supply a grid.getRow and grid.setRow method to get and set the value of those properties for the particular child control. This technique hides what's really going on. You're calling a method in the defining class when you use the grid.row or grid.column property. Does the grid keep track of all of its children's coordinates? Of course, the grid doesn't have any data structure that keeps track of all of the children's coordinates. That'd be silly. The child controls all inherit from dependency object. I'm getting to the point here, really. All of the controls that you can place in the grid or any other container all inherit from dependency object. And this class is defined to maintain an unlimited number of dependency properties. The dependency object class has a data structure which maintains properties for every class that inherits from it. The parent, the grid in this case, maintains a single instance of a field for each property. That means the grid has a row field and a column field. There's a grid.row property, if that's the actual name, for the grid.row property, and there's a grid.column property for the grid.column. The child control maintains its own value for that property. So, calling the parent control's getRow or getColumn or setRow or setColumn method is equivalent to calling the getValue or setValue method of each child object. So the child is keeping track of its row and column. Isn't this complicated? It's amazingly complicated, but it's important to understand what's going on. And to retrieve the grid.row property of a text box, whose name is demo text box, you might use an expression like this. Demo text box.getValue, that's the method of the text box, and you pass it grid.row property. Remember, the grid has a single field named row property that you're using only to pass down to the dependency object's getValue method to get the value of that property for this control. So that's how every child control within a container that has attached properties gets the value of that attached property. We'll see code like this in a future example where we retrieve the value of that grid.row property in code. This is just the syntax, not exact code. In a future example, we'll see how that works.